Good evening, everyone. Welcome to the session number 7 from the playlist of electromagnetic induction. The topic is the rotational EMF, and with regards to this topic, I have written down here two important points, and these 2 points are related to the motion of this conductor AB in a vertical plane. This conductor is hinged at this point O, and this conductor is placed in a uniform magnetic field of say intensity B, and this magnetic field is directed into the plane of rotation. So here the length of the conductor is taken as capital R. Now due to the rotation of this conductor in a vertical plane, the free charges in this conductor will be moving towards the outer ends of this conductor due to the effect of Lorentz force. Because of this Lorentz force, the free charges will start moving towards the outer ends of this conductor, and because of this separation of charges, and EMF will be induced in this conductor. Now, in order to find the total EMF which will be induced in this conductor, I will be considering a very small element of length dr, and as this rod or this conducting rod or this conductor, it moves in this vertical plane, then the EMF which will be generated in this small element of length dr will be given by, that is dE. This will be equal to B into V into dr. Now here V is what? It is the velocity of this conductor which is moving in a vertical plane. Now, in order to find the total EMF which will be generated in this conductor AB, I will be simply integrating this equation within the limits of 0 and R, and so this equation will get converted into this equation in order to find the total EMF which will be induced in this conductor AB. Now we know that V is equal to R omega. So this equation can be further written as V is equal to R into omega into dr. Now this can be written as B omega, and the integration of R will be equal to R square by 2. So within the limits of 0 and this capital R, so I will be finally getting the value as R square upon 2. So the total EMF which will be generated in this conductor AB of length R will be equal to 1 by 2 B into omega into R square. So now this equation can further be written as this equation can further be written as 1 by 2 into B. Now since omega is equal to V upon R, so I can substitute this value as V upon R into R square. So this equation can also be written as 1 by 2 into B into V into R. So the induced EMF in this conductor AB, which is moving in a vertical plane in a region of a magnetic field of intensity B, and this magnetic field which is directed towards the plane of the rotation. So in this case, the EMF which will be induced in this conductor will be equal to 1 by 2 B times omega into sorry, 1 by 2 into B into omega into R square, or it can also be written as 1 by 2 into B into V into R. So thank you very much for joining this session. In the next session, I will be now taking up the numerical problems from the topic of this rotational EMF and the motional EMF. So till then, have a nice day. Bye.